We're going to have a look at a new topic on energetics and how energy is related to chemical reactions. The first thing we're going to look at is endothermic and exothermic reactions and what the difference is. So a little bit of physics first of all. You'll remember from physics that energy is always conserved in any physical process, and it's the same with any chemical process. We always have the same amount of energy at the beginning as we do at the end. It's just that the energy might have been transferred into a different type of energy. So, for example, the most obvious one that you'll have seen in the lab before is chemical energy turning into heat energy. Now, if you observe the thermometer on the right-hand side, then when we have chemical energy turning into heat energy, the heat energy escapes into the beaker, into the solvent, into the surroundings, and it raises the temperature. And when that happens, we call that an exothermic reaction. Now, the word exo means to leave, or is where we get the word exit from. So exit, and then thermic is just heat. So it's the exit of heat. It's heat leaving the chemicals and going out into the surroundings. And we define that as when heat energy is given out to the surroundings, making them hotter. So that's one type of reaction that we come across in chemistry. Obviously, there is the opposite. We sometimes have to put heat energy in order for a chemical reaction to happen. So in that case, if we observe the thermometer again, the reaction would happen and the temperature would decrease, and that's called an endothermic reaction. It's the opposite, where heat energy is absorbed by the surroundings, making them colder. Again, the word literally means heat going in. Okay, so the heat is being absorbed. There's less heat around in the beaker. There's less heat around in the solvent, and therefore the temperature goes colder. So a couple of examples then. Exothermic reactions tend to be things like neutralizations, like displacement reactions, combustion, and many oxidations tend to be exothermic. And if you think about the burning of magnesium, you think about neutralizing acids and alkalis, and that's usually exothermic. Endothermic processes tend to be things like, for example, weak acids like citric acid reacting with sodium hydrogen carbonate or bicarbonate of soda, as you'd find it in your kitchen. You'd use that to make a sherbet, for example, which feels cold in your mouth. But in chemistry, you've probably found it more in terms of thermal decomposition reactions, where we heat something up to break it down, and that's an example of heat energy changing into chemical energy. Now, it's not just about heat, because you can get heat and light and sound all out at the same time. If you've got an experiment which goes particularly badly, then you can get many different types of energy out. But the words that we need to know are for the heat. So different reactions have different changes in energy. Not all exothermic reactions release the same amount of heat energy. If you put more chemical in, you will get more of an energy change. So if you put more chemical into an exothermic reaction, you end up with more heat being given out. If you put more reactant into an endothermic reaction, you'll end up with more heat being absorbed. So because of this, we like to have a way of comparing all reactions, and to do that, we just look at how much energy do we get out of a mole of our reactants. And so we look for the amount of energy, which is usually given in kilojoules, because it's quite a lot of energy given out in a chemical reaction per mole. So kilojoules per mole is usually the measure that we have.